Okay, so in order to integrate sine squared and cos squared, what we need to do is first of all establish an expression. So we could break this up. Now, this comes from if you have cos 2x and you break that up, you get 2 cos squared x minus 1. And if you rearrange that, you get cos 2x plus 1 is 2 cos squared x. So you end up with cos squared x equals 1/2 1 plus cos 2x. Now if you look on the formula sheet, it's got cos squared nx equals 1/2 1 plus cos 2 and x. And you can get a similar expression for sine squared, and that comes from cos 2x again, so it's 1 minus 2 sine squared x. So 2 sine squared x, that means if you rearrange this, that would be cos 2x minus 1 is minus 2 sine squared x. If you multiply by minus, it would be minus cos 2x plus 1 equals 2 sine squared x. Divide by the 2, there you get sine squared x equals 1/2 1 minus cos 2x. So this is also on the formula sheet. They're very similar expressions, but the sine squared one has a minus in the middle and the cos squared one has a plus. So how does this help us actually integrate? So if we want to integrate sine squared x dx, we change it to the other form. So it's 1/2 1 minus cos 2x dx, and then you're able to integrate this. So there's no rule for integrating sine squared because it's function to a power, but there's no derivative there. So the integral of 1 is x, the integral of cos x is 1/2. So it's 1/2 sine 2x plus c. Okay, so integrating cos squared x dx, very similar. Instead of having a minus in the middle, you just have a plus, so it's like that. So that's 1/2 x plus 1/2 sine 2x plus c. Okay, so one that's just a little bit more tricky, but not too much. So looking at this here, that would be 1/2 1 minus cos. Now it is 2x, but we also have this 6, so we go 6x, so you've got to double the 6 dx. So when you integrate that, that's 1/2 x. Now the integral of that would be 12x. So it'd be 1 on 12 sine 12x plus c. Okay, so the integral of cos squared 4x, so change it to the different form. So it's 0 to pi on 4 of 1 plus cos, now it's 2x, so you've got to times the 4 by 2 to get 8x dx. So integrating that, now you get x plus integral of cos is sine, and you've got to divide by the derivative, which is 8. So 8 sine x plus, it's not plus c, because I've got my endpoint, 0 to pi on 4, which is 1/2 pi on 4 plus 1 on 8 sine 8 pi on 4 minus 1/2 0 plus 1 on 8 sine 0. So that's 1/2 pi on 4 plus 1 on 8 sine 2 pi minus 1/2 0, which is pi on 8 plus, now sine 0 is 0. So it just ends up being pi on 8 as your solution.